might be the nearest to Earth. It's also the only system with a black hole visible to the unaided eye. Hey, good news! You're gonna visit it right now! Higher and higher into the atmosphere, and soon Earth turns into a glorious blue sphere. You pass by the International Space Station. Hi guys! But before you can see it in great detail, it's out of sight. No wonder. The largest human-made thing in space is traveling at a speed of more than 17,000 miles per hour. You move further from Earth and see numerous satellites circling the planet. They come in all shapes and sizes, but each one of them has an antenna and a power source, often a solar panel or battery. You reach the moon. It's a cold and dry egg-shaped sphere with the surface strewn with craters and rocks. You see dark areas. They appeared when giant hollows left by asteroids or comets got flooded by basaltic lava. Lighter areas are highlands. The next site on your way is Mars, which is called the Red Planet for a reason. It's covered with fine orange-red dust that looks like talcum powder. The planet's surface is rocky, with canyons, volcanoes, craters, and dry lake beds all over it. You spot a moving dust storm. It looks like a massive tornado, but that's a relatively small one. A large storm can't be seen from Earth. You travel by gas giant Jupiter. The planet is covered in thick clouds, red, yellow, brown, and white. This makes Jupiter look as if it has stripes. The planet doesn't have a solid surface you could stand on. It's just layers and layers of gases. You immediately recognize Saturn thanks to its prominent rings. They consist of groups of tiny ringlets made of chunks of rock and ice. The planet itself is pretty much a ball of hydrogen and helium with no solid ground. Saturn is also the place where winds travel at a breakneck speed of 1,000 miles per hour at the equator. You don't come across any other planets on your way. They must be hiding behind the sun at the moment. Soon, you enter an eerie place. It's huge, cold, and dark. The Kuiper Belt is one of the biggest structures in our solar system. It looks like a donut, with its inner edges starting at about 30 astronomical units from the sun. And 1 AU is roughly the distance between our sun and Earth, about 93 million miles. The Kuiper Belt is the main source of comets. Hundreds of thousands of objects in this area are 60 miles across and larger. Some of them even have their own moons. Well past the Kuiper Belt, you move through the Oort cloud. It's a huge spherical shell surrounding the solar system and stretching for 5 to 100,000 astronomical units. You can compare the Oort cloud with a thick-walled bubble made up of more than 2 trillion icy pieces of space debris. The smallest of these space bodies are as big as mountains. You're leaving the solar system behind and are now moving through the vacuum between different star systems. But this vacuum isn't entirely empty. It's filled with dust and other particles, magnetic fields, and cosmic rays. Finally, you reach your destination, the black hole. It's a mysterious place where the laws of physics people are familiar with stop working. Black holes appear when massive stars collapse under their own weight. The gravitational field of the newly formed object is so powerful that even light, including X-rays, can't escape it. That's why the center of the black hole is pitch black. It doesn't mean you can't see the hole. The greedy thing consumes all the matter that strays too close, squeezing it into a superheated disk of glowing gas. The black hole also bends light around it, which creates a circular shadow. You approach this chaos of heat and gravity in search of the event horizon. Every black hole has an invisible line in the sand. Cross it and you won't be able to escape, even if you're a beam of light. Beyond the point of no return, the gravity is just too strong. But the big circle in the middle is bigger than the event horizon. Anything that approaches the black hole first goes into orbit around it. Once that happens, there's no way back. Whatever this object is, it'll end up being pulled into the hole. This region before the event horizon, called the photon sphere, looks like the black hole's shadow, even though it isn't. If you got there and somehow managed to stay in one piece, you'd be able to see the back of your head. The particles of light from your head would orbit around the black hole at immense speeds and come at you from ahead. Unfortunately, you wouldn't manage to pull it off. Once you started your journey towards the center of the black hole, the difference in acceleration between your head and feet would be many thousands of Earth gravities. You would be spaghettified. But you'll find out about that later. Right now, you're watching in awe how unlucky adventurers surrender to the black hole's gravity and begin their journey toward the end. First, the material gets caught in the black hole's orbit and squeezed into a razor-thin spinning band. Friction, heat, electric, and magnetic forces energize this disk, which makes the material glow intensely. The most massive black holes have such bright bands that they can outshine millions of galaxies. Inside this disk of glowing material, particles rub against one another. It slows them down and sends them straight toward the black hole's event horizon. If this friction didn't exist, the material would be orbiting the black hole for billions of years, like planets circle around their stars. Anyway, you eventually reach the so-called surface of the black hole. By that I mean the event horizon. It's not a real boundary or membrane, and you don't understand you've crossed it right away. It takes you several seconds to realize you won't be able to escape the black hole's clutches anymore. It's not as dark as you imagined it would be. That's because the light, also trapped by the black hole's gravitational pull, is falling in along with you. It's not bright, but it's still there. The longer you fall, the more stretched head to toe you become. This process is what's called spaghettification. You also get squeezed around your midsection, and the beams of light surrounding you form a glowing band around your waist. The last thing you see is darkness. It feels as if you're landing on a massive, empty, pitch-black planet. Hey, back to the black hole. What happens after that? Well, you tell me. Can it be that you just come out of a white hole? Their existence hasn't been proven yet. But some scientists even suppose black and white holes could be two sides of the same coin. Now, if you're looking at it from afar, you wouldn't be able to tell a white hole from a black one. It would spin. It would have a great mass, even if it were as tiny as one atom. A ring of gas and dust would be circling it. But if you watched long enough, you would see something no black hole would manage to repeat, a belch. Only then, at the moment when something comes out, would you realize you're staring at a white hole. It's as if you're watching a black hole's time reversal. And while the black hole's event horizon is a point of no return, in white holes, it's a boundary of no admission. Nothing can get inside, which makes white holes even more mysterious than their black siblings. But even if white holes existed, they wouldn't hang around for too long before collapsing into black holes. Well, I don't know about you, but my brain hurts now. I have to sit down.